Hi everyone, and welcome to the lab. Today I'm going to install a Bluetooth module into this radio receiver. This is a restoration that I did quite some time back. Still works great, but I'd like to have the option of streaming music to this directly. So this should be a lot of fun. So what I'm going to do is get the actual chassis of the radio receiver out of the cabinet again, which you can see right here. That's a bit of a process. I'll get the chassis onto the bench, and I'll share the entire process of installing a Bluetooth module into an older radio receiver. All right, chassis is removed from the wooden cabinet. Very, very heavy radio. Look at the size of that power transformer. 4-gang tuning capacitor. This is good stuff from way back when. Basically, this radio was a communications receiver that was put inside of a wooden cabinet. And it even has high fidelity AM, so it has variable IF bandwidth, so you can get very nice sounding AM out of this radio receiver. Really, really nice radio to own. So if you ever get a chance to own one of these Stromberg Carlsons, I strongly suggest that you pick it up if you see one of these things online. Really, really nice radio receiver, and they work so well. So I've already removed the I-tube. The I-tube sits up in here, and so this is the process that I'm going to go through today. First of all, I'm going to add a Bluetooth module to this thing. I want it to be seamless, so I really don't want to add any extra controls to the radio, no toggles, no switches on the back, things like that. I want this to all be done through the existing controls. I also want to make this modification very easily reversible. So say someday down the road it's desirable to remove that modification, it can be done, and pretty much almost no trace will be left. You know, very minimal hole drilling to the chassis or anything like that. If I can get away from drilling holes at all, I will definitely not drill holes. So again, a nice clean install. That is the goal of this. So the best way to do that is to install a switch that'll activate at the end of the dial. So basically what happens is you're tuning through the dial, the radio operates completely normal in all of its functions, but when you come right to the end of the dial, a little switch goes click right at the end, and now it transfers the audio from the radio itself to the Bluetooth module. So it picks the audio off the Bluetooth module, and that's what's going to be done today. So I'll take you through that entire process as I'm adding this module and all the little troubles that I run into as I go and install this thing. So the best way to do that is somehow add a switch onto the tuning mechanism here so that it will activate. So we have to find a nice free area that, you know, I can pick a switch out of my junk box and add to this. So I'll zoom on into the mechanism here and let's take a look at the best area to put that switch. Well, this looks like this could definitely be a tricky install, so I figured maybe I could have this activate the switch, but where it gets tricky is this area comes up on the other side here and would hit any lever or arm. And of course it covers up these screws down here as well, so as this comes up to this area, it's completely covered, so I can't use that. So, you know, I could use maybe this one, or there's a hole, a factory hole drilled in here. That looks like it might be the better option, so what I'll probably do is remove one of these set screws, this one up here, and put a long threaded screw in that, and that'll hopefully click or activate the switch. So I'll remove that screw. These are it's a pretty common thread size to these. How can you tell I've done this kind of stuff before with these radios? So I'll get this in here like so. Hopefully you can see all this. And they're not usually that long. Oh, thank goodness for magnetized screwdrivers, right? Okay, and they're usually this thread. Let's see if it's correct. This one right here. I don't want to force anything in, so let's see if it spins on the top. And it does, yeah, so it's pretty standard. I'll just snug that in there for now, just so I can kind of see, get an idea of what's going to go on. So you can see there's a short one there and now a long one there. Now that gives me an arm that I can, you know, kind of a movable arm that I can tap this switch with. So this is obviously going to be too long. So if I mount this, say, on here, I'll try and hold this in here so I can show you. You can see how that could touch that, right? And then that might actually work. So if I was to, say, mount that and have this come over like so, I don't know where the screw is. So this would be the mounting hole right there. So if I put that in, see that? Looks like it might work, right? You can see that there. Not the camera trying to defocus on me here. So if I mount that up there, you can kind of see it would come around and kind of use the rounded head of the screw as well, so it'd be nice and smooth. So I think that's going to work. Now this is too long, of course. It's going to hit this thing here. It's definitely going to hit this. So I'll have to shorten this up. So I'll get on that, just cut this with a pair of 10 snips or something like that, and tighten that down and put a screw through this. Now I don't want to really drill any more holes, so I'll probably put a star washer on this side or something and tighten it down really good so that it has lots of grip, and then that way I don't have to drill any other holes and mount this any other way. So I think that's going to work. So I'll get that screw installed and let's see how well this fits in here. It's even finger tight and it's already gripping. It's getting pretty tight. So that's good. I think that alone will hold it, since there's a lock washer on each side. You can see that in there. So let's see if we can make this activate. Okay, so I'll bring this over here. That's where the screw is. Look at that. So, of course, it's not tight yet, but looks like it'll work well. The switch installation is complete. Went very easy. I had to replace the screw though with one that's just a touch shorter. The other screw was hitting the arm of the switch just a little too high up. This one here perfectly hits that little paddle on the bottom. I'll show you. So as you can see there, shaft moving around here. So I'll bring this right to the end. See how it touches the paddle? And clicks that switch on and off. So that uses all the existing holes. There was no modifications on the upper portion of the chassis at all, other than just, replacing that one set screw there with this longer screw. So that worked out very well. Another thing to keep in mind if you ever install any of these switches is you never want them to bottom out. See how there's extra travel here? Right? You don't ever want to bend the arm of the switch. So there's quite a bit of free area there still. So just enough to activate the switch and a little extra travel just to make sure that it stays engaged. So the switch stays in its on position there. First time this has been opened up since the restoration. And it all looks the same. That's there from many, many years of this radio probably being operated with bad caps, and of course things getting hot. It's very common for the tar on these old transformers to run like that. So whenever you see that, it doesn't necessarily mean there's a bad transformer, it just means that it's been hot. So this is the volume control down here, and the Bluetooth board will have to be mounted somewhere within this area because this is a volume control, and it's going to have to tap into that amplifier stage there. We'll take a look at the schematic in just a moment. So this is the little Bluetooth board that I'm going to be using. They pretty much all look the same, and these things are available everywhere, so you can find these on all your favorite online shopping sites. So that's the little one that I'll be using right there. It works very well. And this particular one doesn't have any announcement or anything in it. It just kind of turns on. So when they first initialize, sometimes in the circuit, you'll get a popping noise as, it comes on, or, depending on the board, right, and who's designing it. So I designed up a small little circuit board here, and I recently released this in all the plans, the circuit board layout, the population map, the schematic, everything for this is on Patreon. And I did another radio just like this on Patreon. If you haven't seen that, or if you're not on Patreon, there's another one done, not the same model, different model, but another very desirable radio to own. I installed this particular board here, and I also installed this particular board in that one as well with a switch, just like you saw in this one. Everything, of course, every radio is its own kind of adventure because you don't know where you're going to put the switch, just like this one. I had absolutely no idea when I started this where anything was going to go, so this is all real time. So this has to be mounted in here, and this Bluetooth board will have to be mounted in here somewhere. So I'll locate an area, we'll take a look at the schematic, and I'll show you exactly how these get wired in to make this work. Let's take a look at the schematic for this radio receiver, and I'll show you exactly how I'm going to install this Bluetooth system. So the area of interest is the volume control over here. So I'll just zoom on into that, and we'll take a closer look at that section there. So after the last IF amplifier stage, we have the detector, and this is the audio path into the volume control from the radio itself. So the radio's audio comes right through here. In order to feed the Bluetooth audio in, I need to break this connection and tap the Bluetooth system in, and that's where this little circuit board that I've designed comes in handy. So this relay has two sets of contacts on it, and what it's going to do is it's going to open the radio's audio path and connect in the Bluetooth's audio path with one set of these contacts here. With the other set of contacts, here's where the trick comes in to make this work very well. The other set of contacts is going to lift the cathode of the last IF amplifier. Why am I going to do that? Well, I want to render the radio completely silent when the Bluetooth system is in. These stages have so much amplification that even when this is switched over, so when this section here is switched over to the Bluetooth, there's still a chance of hearing some light hiss in the background, or even just say there's a radio station right at the end of the dial or something like that. There's a chance to even hear a bit of that audio in there. So in order to render the radio completely silent, it is necessary to basically shut down the last IF stage, and that's what this other set of contacts is going to do. Now, this board also has a delay setup on it, and it also has the regulation for the Bluetooth board because the Bluetooth board needs a regulated 5 volts. So this little regulator here regulates the filament supply of the radio. So I'm going to use the filament supply in the radio in order to power this entire Bluetooth system. So there's a lot of things going on this board. There's also a delay circuit in here. So what happens is when power is applied to this board, this relay does not click in right away. It waits a short period for the Bluetooth board to initialize and get through its noisy stage. Then after that's all done, after a short delay, this will click in and do all the switch over. So there's a lot of stuff going on in this little teeny circuit right here that makes this a relatively seamless interface. So taking a look at the power supply over here, this is the filament supply right here, and this is where I'm going to create the DC, the unregulated DC for the Bluetooth system here. So that's going to go into this point right here, it'll go into the regulator, and then this will run off to the Bluetooth board after it's regulated. This also performs a little bit of ripple filtering as well. I talk a lot about the internal circuit design, everything about this in my Patreon electronics course. It's all explained very well right there. So in order for me to create a DC supply, it's very simple in this radio. So all I need to do is put a diode on here and a filter capacitor, and I have my supply. Now, on the previous radio that I did, I switched the entire supply in and out from the AC side with that switch that I just installed on the upper portion of the chassis there that, you know, switches on at the end of the dial. Now that can be switched in. Either you can use it to switch the whole power supply in, or you can use it to switch just the DC side on and off. It really doesn't matter. So I'll see how everything fits in here, and of course I'll explain exactly how I've done that here. So that's another thing I need to do, is I need to attach a diode to the filament supply in here and put a filter cap in, make a quick little power supply that'll run off to this board right here. So it's another thing that needs to be done. So there's a few steps that need to be done in order to do this correctly, but in the end, you know, it's really quite worth it. That Bluetooth modification makes these radios sound just perfect, and really makes it sound nice. I found the locations that I am going to install the power supply, the little control board, and the actual Bluetooth. So first of all, the power supply will be put over here. So it's just a diode and a capacitor will be on a little standoff right here. So this is the filament supply right here, and this runs up to the switch. So this is going to switch the AC side. So basically from here over to this little terminal tie strip that's going to have the diode and the capacitor on the filter cap. Then a lead will run behind here, which is already soldered to the board, because this is going to be hard to get at once this, I'll just bend this up here, once this is installed into this little area right here. So that'll be installed like that. So this little transformer here, basically an inductor, this forms a filter network for the audio, was mounted right here in this hole, and there was a hole right here. So I just put a standoff here, and this will just get mounted here in the future. Now I have to be careful with this because this is a sensitive audio section, and even just touching this will introduce hum into the audio. Now there always is just a slight bit of buzz in this radio receiver, just because of the way they've wired things, even when this was down here. So I've compared that, and I'm prepared to make any adjustments that will need to be made. This here seems to be a decent location, so the hum is not bad, but if you get this really close to the reactor over here, you'll start to hear buzz. So it seems to be kind of a null spot here, which is okay. So this will get mounted in here. The way I'm going to mount this is I clean the chassis, and I'll sand the back of this little printed circuit board here, a little bit of tar on that from the transformer here. So I'll sand the back side of the circuit board down and put a dot of super glue right in the center of the board. I'll clean this off with, probably sand this down just a little bit with some, maybe 800 grit sandpaper. And then place this on here, and almost immediately once you do that with super glue on the back side of the board, it's stuck. So no holes are drilled to get this mounted inside this radio. To get this off, once you put super glue under this, it's kind of a I guess you could say almost a permanent thing. So this is going to be stuck here for a long time. This is the ground. It'll mount right up to this little ground tab here. So from the ground up to here. And that leaves this hole open, so just in case I need to add a terminal tie strip here, like so, to add, maybe more connections to wires or things, it leaves me some options to have that right there. This is close in the audio section, so the leads will be short, keeping any type of noise down to a minimum. And then, of course, the cathode leads that run up will have to be coax up to this area here. This is what needs to be broken. This is the cathode of the third IF amp right here. So this will have to be broken at this point, and then a lead run down to the relay and then back up to the cathode there. So this is, a little bit of an in-depth install, but once this is all in, it actually goes very fast. It sounds like a lot, but it actually goes very fast. You look at this and you're probably thinking, how long did it take to make this thing? This little board here took, no kidding, 15 minutes to populate. It was ready to go. So made right here, very simple. So it looks in depth, but really it's not bad at all. It's not a bad install at all. So now, in order to mount the little Bluetooth board, this is where I had to drill 2 small little holes here. Now there's holes all over the face of this thing, so they just blend in. I'm not really worried about it. They've got factory punched holes everywhere on this for different options. So the Bluetooth board itself is also wired and ready to go. So all of the wiring is kind of put on, and then you leave excess wire that you can just basically cut off at any time. The ground for the Bluetooth board runs from the little negative on here where it says battery to this threaded little screw here, and it's soldered onto that. And then once this fits on, these wires will tuck underneath, as you can see with this one here, and this will just mount to the face of the radio. So this goes through here, and so will those white wires come through this little hole, and this just mounts onto here just like so. And there'll be some spacers and standoffs under this just to give it a bit of room. Now, the reason that this is on the outside of the chassis and not on the inside of the chassis is because the chassis acts as a shield, and this is an antenna right here, right? This is what picks up the signal right here. So this needs to be outside the chassis. It can't be hidden under a metal chassis, or of course this thing isn't going to receive, or at least not receive very well. This doesn't have a metal bottom on it, so the actual chassis itself does not have a, it's got this kind of a fibrous, this thing here, this kind of a fibrous bottom. So it's not too incredibly bad, but still it's covered up. So of course I want the best reception I can, get with the Bluetooth. So this will have to be mounted on the outside. You can put a little cap on this. Little project box would fit right over top of this on the outside. So if you didn't want to see this, you're not going to see it anyways because this is up against the front. This is, the dial, right? The wood is right here on the front of the radio, so you don't really see it. But if it is desirable to cover the circuit board up, a little project box or cap can fit right over this. I did that in the other install, the other Bluetooth install I did in the two-part series, the instructional series on Patreon. I put a little cap over it. It was actually just something out of my junk box. It was a part of an old relay that I put over top of it, and it fit perfect. So anyways, yeah, that just fits in here. This will get cleaned off. This grounds to here, so the Bluetooth board is just grounded to the chassis. This is the positive. This will run off to a terminal tie strip that will fit over here. The Bluetooth obviously outputs stereo, so what we need to do is make that mono. So I'll run a couple of coupling caps, and then also I will give this a bit of load. So probably put between 82 and 100 ohm resistors on the output here. So basically it mimics headphones. And I'll explain all that, and I'll show you all that once this is all wired in. The Bluetooth modification is finished, and it works fantastic, and I'll display it in a moment. I'll show you exactly what I've done here. I have to admit, this modification took a little longer than it normally would, just because I chased down an issue that was actually created at the factory by Stromberg Carlson. Now, it wasn't a major thing at all. The hum level with the volume down was a little bit higher than I would have liked. So, for example, if you have one of these older radios, if you go right up to the front of the radio and you put your head close to the speaker, it's normal to hear a little bit of buzz, a little bit of hum. That's about it. All right. If you back a foot away, it should be relatively silent, right? So just a little bit of noise in the speaker. They have electromagnetic speakers, and the filter caps on these are pretty small for way back when. It has choke filtering and all that kind of stuff, right? So a little bit of buzz is expected, right? So this one here, you could get about 3 feet away from it and still hear the buzz and the hum in a silent room, and I was never really happy with that. So I chalked it up to just the personality of the radio, and I left it there. And, not a big deal, but now that I have a Bluetooth system in here and it's going to have really nice audio, I don't want any of that. So I started chasing down the hum. And, it actually took quite a long time because it was present in a lot of areas, and it was just because of the way they loomed the wires at Stromberg Carlson. So this has got a very interesting phase inversion system. They used a transformer in this thing. Basically, it's somewhat like an inductor as a phase inverter. All right. So, and that's this big block right here, right? Lots and lots of winding in there, right? Very high impedance. You know, the DC resistance measures 4K. It's 7K end to end on that transformer. So there is a lot of windings in that transformer. So because it's attached to the grids of the output tube, they're both output tubes, you know, it's a relatively sensitive circuit. Well, what they had done is they had ran the leads under this wiring harness here and then up to the well, it's basically an inductor up in here, all right? We'll call it a phase inversion transformer just for argument's sake. So, and they ran it right below this loom. Well, this loom here carries filament current. It also has the AC switch line, so it's carrying the current from, you know, to the main transformer. There's a lot of things running underneath here, right? There's AC all over the place. So, and then of course, rectification, you know, you've got the actual B plus lines coming from the transformer and running through there as well up to the rectifier. So that's where the buzz comes from, because of course, you know, we're getting rectification and they create a bit of buzz, right? So what ended up happening is I removed the leads from under this harness here, right? Under this, you know, loom, I should say, that ran to the grids. And I cut them very short and ran shielded coax right up to the grids of both of the tubes. And I'd have to say that got rid of 90% of that buzz. That speaker is almost silent, like probably one of the best that I've ever heard for these older radios. So it makes me wonder if Stromberg Carlson maybe down the road shielded those. Maybe they had complaints. This is a very early chassis. I believe this is number 138 is the number that this one is. So this will be the 138th one that they made. So, you know, probably early in the run, maybe things that they just overlooked, you know, or, you know, just expected that kind of a bit of a buzz. People would be tolerant for it. I'm really not quite sure. So that was the first part. And the rest of the buzz that was in there was taken care of by shielding the actual lead to the tone control up here as well. So the shielded lead running up to there. So they ran a lead here. I think I still have the wire. That's the length of the wire that was running, you know, from down here all the way up through here, around, and all the way down and up and over here. And that is below AC lines, and it's tied right into a high impedance circuit. So this thing is just a hum magnet. Getting rid of this thing got rid of the other 10%. This got rid of most of the buzz, and the shielded leads got rid of most of the hum. So quite a modification. So if you ever get a 145, that's a very worthy modification. You know, these coaxes in here up to the phase inversion transformer and right down to the grids and then shielding everything. The modification that I've added, you know, added pretty much nothing. There's zero buzz, nothing. Of course, because I'm using all shielded cables and everything, right? So, you know, took a little longer than expected. Well, actually quite a bit longer than expected, because I had to chase all this down with a scope and you know, open the grids up, bring them to ground with 470K resistors, and then see if there's buzz, and then scope the actual transformer itself, and then found that the buzz was actually on the leads. 70 millivolts of buzz on those leads. So just crazy. So anyways, it took a little longer than expected. So back to the Bluetooth mod down here. So this is the power supply that's installed for the Bluetooth mod right down here. So basically a Schottky diode. There's a resistor here to minimize hum or switching noise from the diode. We have a capacitor here. There's a bleed off resistor here, so that'll bleed that circuit down a little faster, so it'll click out a little quicker, because that is quite a bit of filtering. So basically that setup is this here, 0.47 of an ohm. We have the Schottky diode. I've got this a 220 ohm resistor here, and then a 6800 microfarad cap right there. And that runs off to the little board, which is right over here. So the little board is in here. So that's just basically, as I say, I use super glue, push that down. This is grounded to that terminal back there, and then of course all the coax runs to the terminals here. The actual, this side here switches the cathode out, and this here switches this is the cathode of the third IF. This one here switches the audio back and forth. So what I did here is doing this all on camera here. So I opened this right at this point here where that X is. So that's where it runs down to the relay. So the cathode runs down there. This cap here is still on the cathode. So the cap is up here, and then the rest of this is all on the other side of the relay. So I moved this to the open portion. So that opens with this is left on the tube, and then this runs down here. So this, the reason that I couldn't open the whole system up, just leave everything and, you know, open it down here, basically just open the ground, is because what happens is the I tube is also connected to this. You see this? So what's going to happen is the I tube is going to go dark if I do that, if I open this up. So I want the I tube to remain on because it looks like the radio's in normal use. That's the reason it got broken up here. All right. Yeah, the audio control was broken right where I displayed earlier, right here, and that portion is the audio control. If I move this over, you can see here the audio control is right there. So this got broken. So this is the wiper that runs in from the circuit, right? And then we've got the audio control that runs down, and of course the Bluetooth also ties into the board on the bottom there. So this is the Bluetooth audio out area. So the audio out is these two white leads, and they go through these two caps and then down through the shielded coax down to the board. On the other side of this, there's also some 82 ohm resistors that bring these two leads, so it makes it think that there's headphones on there. All right, so there's an impedance, a load on this. This red lead is the positive. It just runs to this terminal tie strip, and then that red lead you see back there runs down to the board and ends up right behind that terminal tie strip that makes it a little difficult to see. I'll see if I move the camera here. Pardon the movement and the bumping. There it is. You can see those two little, something to point with. You can see the red lead there and the yellow lead. The yellow lead comes from the power supply, and the red lead runs off to the Bluetooth board up there. If you, yeah, you could just see the 82 ohm resistors right in there. So one there and one up there, and they're just from the two leads to ground. The Bluetooth board itself is on the front of the unit here. Hopefully I can get this all into focus for you. So the Bluetooth is mounted right on the front. Now it has to be mounted, see, this is completely out of sight. All of this is out of sight right up to the bottom of the glass. So this is just all wood in front of this, and you can't see this whatsoever. Now I will probably put a cap on this just to protect this, you know, from any type of bumping. The only issue is fitting this radio back in the cabinet is very tight. You have to tilt the chassis forward and put the I-tube and everything underneath the chassis and then lift it up and under, because they put a ridge on the back of the cabinet. So I have the cabinet over here. I can just show you that. So they put a ridge on the back of the cabinet. You see that big piece of wood here? So this thing here, so you have to put the chassis up under here and then push it in. And the clearance on the front of this is extremely tight. On the front of that is extremely tight. So I have to be very careful, because I'll actually push this cap up right here if I'm not careful, because it just clears this. So putting a box on this may be an issue, so I'll have to experiment with that. It works just fine like this. Now the reason this is on the outside of the chassis again is because this is an antenna, and if I mount this under the chassis, it's going to shield this entire board, and I'm not going to get very good reception. So that's the reason it's mounted on the outside. And it's fastened, like, you mean, that's on there tough. That, you know, definitely would not come off at all. So that really is the modification, just lots of time put in. So what I'll do is I will maybe I'll search the YouTube music library for some music that is, I guess, is classified as royalty free or whatever, and I'll find something and turn it on, and we can take a quick listen to how this thing sounds right here. I'm about to power this old radio up now, so please note that all of these older pieces of equipment, televisions, radios, test equipment, guitar amplifiers, they all have elevated voltages inside them. So you need to be very careful if you're working on things like this. If you're not familiar with electronics like this older electronics, I strongly suggest that you do familiarize yourself before you dive into anything like this. So if you're following along, you're doing so at your own risk. All right, I'll turn the radio on and let everything warm up, and I'll explain what I'm going to do here. So first of all, it's on the radio right now. I'm in the AM broadcast band, so I'll tune this through the band to the end, and I'll bring it right to the point to where it goes click and turns on the Bluetooth system. So what you're going to see happen here is you're going to see a little red LED on the board that I've designed down here, and you're going to also see this little blue LED flash at the same time. So this will flash and this will just come on solid red. What's happening is the little board that I've designed is waiting for the Bluetooth board to get through any type of power up, noise, pops, or anything like that. After a short period, the LED down here will turn green, and at that point the switchover happens, and that's only just a few moments. So when the switchover happens, it opens the cathode of the third IF stage and also switches the audio from the Bluetooth into the audio amplifier section of this radio. And of course, it's switching the actual radio portion out at the same time. So this little board is doing quite a few things here. So as you can hear here, it's on the AM broadcast band. All right, so what I'll do is I'll tune this to the end. Turn the volume down just a touch here. I'll tune it right to the end of the dial and keep an eye on these two little LEDs. All right. So I'm just about to the end. And silence. That's just the way I like it. Those modifications are great. That speaker is just sitting quiet. So right now, this is on the Bluetooth system, just like that. It switches over just that quick. So let me get that royalty-free music happening here, and we'll take a quick listen. All right, it should be playing. Isn't that nice and clear? Just crystal clear. It's absolutely fantastic sounding. So what I'll do is I'll put this back into the radio cabinet and let's see how that changes the sound. Again, this is just my lapel mic here, so it's picking it up, but I'll put it back in the actual Stromberg Carlson radio cabinet and put the speaker in, and we'll take a listen to it in that. Well, hopefully the lapel might pick that up okay. Sounds incredible on this side. It almost sounds like this has a tweeter. It picks up the highs. It just sounds so great. So if you're interested in learning more about installing Bluetooth systems into radios, definitely check out my ongoing electronics course on Patreon. I have another 2-part episode showing how to install this with, again, all the plans to build that little board and yeah, all that great stuff. Are you interested in learning more about electronics, both modern and antique electronics alike? I teach electronics in a way that's very easy to understand, complete with circuits for you to build, and over 200 videos at this point for you to learn from. I even share my electronic inventions and creations there as well. If you're interested in those, you can find them on this channel or all over the net. So there's lots of stuff for you to learn from. Circuit diagrams and plans and circuit board layouts and component layout maps, and all of that stuff is available in my electronics course for the circuitry that I teach you on and the inventions that I release. So you're definitely going to want to check out my ongoing electronics course on Patreon if this sounds interesting to you. It's extremely affordable, and I'm there to pass my electronics knowledge on to you. That's why I'm here as well. Definitely check it out. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comments section. So if you click on one of those links, it'll take you right there. If you enjoyed this video, you can let me know by giving me a big thumbs up and hang around. If you're new to the channel, don't forget to subscribe and tap the bell symbol if you want to see more great electronics footage. There's lots of stuff coming. I've got lots of repairs and restorations and troubleshooting procedures and tear down videos and all of that stuff on this channel, because that's what I'm all about. This channel is all about electronics. All right, until next time, take care. Bye for now.